1, 2, 3, come on!
Come on, come on. Come on, come on.
Okay, we have perfect cube. So when can we say that a number or term is a perfect cube? So before that, let's discuss again a perfect square. And what is the difference between the two? So we have here 2m times 2m. So multiply 2 times 2 is 4. And n times m is m raised to 2. So how come? Because 2m can be written also into 2m raised to 1. So if we multiply the same variable, so copy the variable which is m and add exponent. 1 plus 1 is 2. So this 4m squared is what we call perfect square. And this 2m times 2m can be written also into 2m, the quantity of 2m raised to 2. So a perfect square, there's an exponent of 2 if a term is raised to 2, and that is a perfect square already. Okay, so how about if I have here 2m times 2m times 2m. So multiply 2 times 2 is 4. Then 4 times 2 is 8. So this 8 is a perfect cube. And again, for the variable, so there's 1 in every exponent or in every variable, right? So 1 plus 1 plus 1 is 3. So 8m cube. So this 8m cube is what we call a perfect cube. Okay, let's have another example. We have here negative 5a squared times negative 5a squared times negative 5a squared. So multiply. So negative 5 times negative 5. So positive times negative times negative. Okay, sorry. Negative 5 times negative 5. So that is positive 25, right? And 25 times negative 5 is equal to negative 1, 2, 5. Okay? Because positive times negative is negative, or negative times positive is negative. So vice versa. They are the same. Okay? And for the variable, the same. A. So copy A. Then again, do not multiply. Okay? So add 2 plus 2 plus 2. So this is 6. And negative 125a raised to 6 is a perfect cube. So can you give me the definition of a perfect cube? Okay, let's have perfect cube. So when can we say that a term or a number is a perfect cube? So let's go back first to a perfect square. Okay, so we have here an example of a perfect square. So we have 2m times 2m. So multiply. Okay, 2 times 2 is equal to 4. And m times m is equal to m squared. So how come it becomes m squared? Because 2m can be written also into 2m raised to 1. So if we multiply the same variable, so copy the variable and add the exponent. Okay, add, don't multiply. So this 4m squared is a perfect square. So again, 4 is the numerical coefficient, which is a perfect square, and the exponent should be even, and that defines a perfect square. Now, what if we have 2m times 2m times 2m. So multiply. So 2 times 2 is 4. Then 4 times 2 is 8. Then m, so the same base, so copy m. Again, there is 1 in every variable which has the exponent of 1. So copy, add. 1 plus 1 plus 1 is 3. So this 8m raised to 3 or 8m cube is what we called a perfect cube. Okay, let's try another example. We have negative 5a raised to 2, negative 5a raised to 2, or negative 5a squared, negative 5a squared. So multiply. So negative 5 times negative 5. So negative times negative. So we will expect that the answer is positive. So negative 5 times negative 5 is positive 25. And positive 25 times negative 5 is equal to negative 125. And then for the variable, so they have the same variable, so a, and add the exponent. 2 plus 2 plus 2, that is 6. So the result is negative 125 or negative 125a raised to 6. So again, don't multiply the exponent. Okay. So in this perfect square, this 2m times 2m can be written into 2m, the quantity of 2m raised to 2. So a perfect square, there should be an exponent of 2, or the whole term is raised to 2. In the perfect cube, the whole term, so this 3 can be written also into the quantity of 2m raised to 3, because we multiplied that term into 3. Okay, so we will multiply itself into 3. So 2m times 2m times 2m is 1, 2, 3. So therefore, this is the quantity of 2m raised to 3. So the same with this one. It can be written as negative 5a squared raised to the quantity of negative 5a squared raised to 3. Okay, and the result is negative 125a raised to 6. Okay, I can suggest to you that you can make a perfect cube tables, especially to those students who have this subject. Okay, so for example, we have, if I will make 10, so 10 in a perfect, first is you need to make a perfect square table. For example, 10 times 10 is equal to 100. So this is a perfect square. And for the perfect cube, so 10 times 10 times 10 is equal to 1000. So this is a perfect cube. Especially to those who have a hard time to identify a perfect square and a perfect cube. Also with the negative sign, like for example, we have negative 10. So negative 10 times negative 10 is equal to positive 100. And here, negative 10 times negative 10 times negative 10 is equal to negative 1000. Okay, let's try to identify which of the following is a perfect cube. Okay, let's have number 1. So 16m raised to 15. So is that a perfect cube? So this is not. Why? Because here the 16 is not a perfect cube, but it is a perfect square. So it makes the term not a perfect cube. Okay. Here 9m squared. So 9 is not a perfect cube. Okay, it is a perfect square. And this 2 is not divisible by 3. So this whole term is not a perfect cube, but instead a perfect square. Okay. How about number 3? 27b raised to 10. Here, 27 is a perfect cube, but 10 is not divisible by 3. So therefore, this is not also a perfect cube. How about number 4? So 343. So 343 is from 7 times 7 times 7. And 12 is divisible by 3, right? So 12 divided by 3 is 4. Okay? So this makes the term a perfect cube.
1, 2,